Hello, and we're back for part 2 of our project, trying to recreate classic Mega-lo-Mania in Unreal Engine. Now, yesterday, yesterday we didn't get very far. There were some issues with importing the sprites, and we overcame that to a point. Some of the sprites still aren't imported correctly. And then the next task was to try and animate one of those sprites, in this case the Stone Man animation. Now, the way that we started with that was to create a single flipboard with all frames of all directions. So we've got 15 frames and the character walks in each of the directions. The theory was that we could use the blueprint to control the direction in which the character was facing, and thus the animation. That was working to a point. We managed to get the character, if we just go press play, and find the character here somewhere. Maybe even known. Where's he gone? He's not, the blueprint's not on there. Let's put him down. There we go. We'll sort his location out in a moment, but we managed to get him to display, and they iterate through the first 15 frames, and then it got stuck on the 15th frame because we are not setting the limitations of the particular direction. Now, after some research and watching other similar implementations, it's clear that having a single flipboard, flipbook, with all of the directions is just not the way to do it. It might work, but we're removing some of the kind of implementation that comes for free for the flipbook and trying to implement it all over again. So we also have found some more assets for the game. So if we look at the original assets, my intent is to use the original graphics, the original sounds, to basically try and make like for like. Now, once we get past the actual core implementation, once the whole game works, then maybe we'll look at making some different graphics or something like that, but I'd like to make it using the original graphics. Some of them were easy. The LBM files just loaded in GIMP with an extension that we covered yesterday, but it's evident that there's a lot more images that we couldn't get hold of, and I haven't figured out how to actually get them, but I did find a website that had some of them, if not all of them, available. So I've grabbed them and downloaded them, so we can see that we've got these MLM pictures. Now this one is the same as what we already had, so this is the two files that we exported yesterday, or resaved more than exported, but they're identical to this PNG that we've downloaded. And we've also got which ones are the icons, so that's all of the little bits and pieces, the icons, the font, a whole bunch more stuff in there. And what is actually in there, skipped ahead a bit, is the unarmed man that we couldn't find yesterday. So the right hand side, the armies, actually is, as the name implies, all of the units, I suppose, for want of a better word, from within the game. And the unarmed man that we actually see when we just place some standard people onto the map are within the icons, so we can use them. There's obviously a whole bunch of icons that we'll need to extract moving forward, and for some reason we've got a few of the men in various states up here, kind of in the top right section of the image, and there does look to be a few squeezed in here on the bottom left, and somewhat on the bottom right. So they're all over the place. So that's going to make it kind of extra tricky to get everything in place. We also have features for the actual gameplay area and the little islands that are used to display the minimap. So we've got quite a lot, let's say if not all of the graphics that we'll need to make this work. So what we're actually going to do is remove all of the stuff, I think, that we have already created. Oops. Except for the default level. That may take a few seconds. Because while the sprites and the images probably are all the same, it will be cleaner if we just have everything from the same set of files. It's taking a little longer than I expected. But we're not losing anything with our animation because I know how to do it better today. I know how to create the sprites that we did. So we should be able to recreate and get back to where we were quite quickly and quite easily, and it's also a good refresher to show what we did. There's obviously a lot of sprites that is extracted from the previous file, and we'll try and organize them again somewhat better than we have here. Now we know not all of the sprites are going to extract correctly, so we might have to create individual sprites from the file once we've got the primary ones out anyway. Okay, so we'll just get rid of everything. Another delay. So we're going to use, as I say, the MLM files. And this one here. I don't need those. It is, as I say, identical to what we've already got, but we'll use the PNGs, slightly smaller file size, because yesterday we tried saving the file as a bitmap, see if that helped with extracting the sprites. It turned out that the default sprite extraction process seems to rely on things being in a consistent grid, and obviously with these images, all the units, the little character people, they're pretty much in the grid, but then we've got the airplanes, the missiles, the spaceships, and the kind of weapon, bullets, spears, arrows, etc. They're all outside of the grid, so they didn't work. Okay, so now we've deleted everything we had and effectively started again. We can quickly import our armies PNG, and this is known as a texture, so we're going to try and keep the organization good this time. So we're going to quickly move that into our textures directory, and then from that texture we're going to extract sprites. Again, this is pretty much what we did yesterday. Before we'll do that, we'll just change the texture mode, I think it was. Something to do with the texture, if I can remember what it was. Texture group, thank you. Welcome back. Texture group. I did do a little bit of research on what the texture group was earlier today, but alongside everything else, and I can't find the texture group. Maybe it's in here. There we go. Texture group and 2D pixels. So at the moment, just to clarify the purpose of this, as we can see, if we zoom in, it goes nice and blurry, which would be great if we wanted kind of the anti-aliasing kind of effect, smoothing it out, but with a pixel game, with this art, doesn't look good, isn't what we want. So if we change it to 2D pixels, it removes all the blur and we get the clear-cut images again. And that's great. So from that we will extract our sprites, and just to, again, to go through it, if we extract like that, we say do auto, perhaps we'll give it the right background color. You would expect that to extract something, but it doesn't. It gives us one sprite of everything, so that's no good. Now we can create individual sprites of the various things that we need that the grid doesn't work with later on, but we will extract sprites again. We'll use a grid. We know that the cell width is 16. Just type that in. And we know the cell height is also 16. We don't need to know about the number of cells in either direction because it just extracts it to the end of the file anyway. We could in theory cut off that last row, but again I don't think it will extract actual images that are blank, and even if it does we can clean them up. Now we can see that some of the aircraft, missiles, spaceships, all of them don't fit, and perhaps there is a little bit of offset for some of the lower items. I'm not quite sure if they are fully in the grid or not, but we'll deal with the images that don't work later on. So we were actually going to, I won't do that because we were going to work on the actual little men with no weapons that are in this file. So we'll set the texture group for this one again. Texture group, 2 pixels. So in this one it makes it more difficult for us in the sense that all the little men, they're all over the place. We've got the same amount of frames, I think, they're just in different places. So we may have to extract the sprites individually, but we'll see how the 16 by 16 grid goes, see what we get from that. So yeah, we can see that some of the characters in this case, some of them are completely off. Now what we can try and do, didn't work. Yeah, so the margin moves things over and we'll move things down. It's going to be difficult to get because of the way that this particular file is handled. I think it's going to be a little bit awkward to get all of these little men and the little men down here and here within the grid, so that doing it by grid would even work. So I guess we are forced to just do it individually. So we can edit the source region of our sprite. So we've created this sprite with all of the image. We can edit the source region. We can just resize that, I think. Why are you not letting me edit the source region? Maybe we just need to reduce its size first. An image region, select all connected pixels. Okay, so does that actually work? No, that doesn't seem to like to just work. And for some reason the handles don't drag either. Okay, so it says hold down control and drag. Still not great because my dragging completely missed then. Yeah, so these ones are actually smaller. So click on another. See if we can get this one lined up straight away. It's particularly awkward unzoom and zoom, but we're 260, 12, 14. So we should. I don't like the way it resets the zoom every time I do that, so I'm just going to quickly throw some boxes around them to define the sprites, and then we'll make them a little bit more precise all in one go. We'll obviously have to make sure each of the images are the same size as, so that the animation lines up, but I think we can adjust even with different sized sprites. We can adjust the animation so that the actual animation works smoothly. So issue now is just make sure we capture all the little guys which have spread themselves out over this file. I think that is all of them. Yep. So now we'll just go back through them. Oh, it's still going to reset my zoom every time I highlight one. I don't think there's a way to stop that. I'm not quite sure why it even does it, but so that's 2, 4. It's not right. Oh, that was right. Okay, so we'll just go through each of these, fighting the awkward editor. That needs to be 260 and 12. I think that's 12, 14. So they're all 12 by 14 as it's so far. Which helps a little bit. That one's not too bad, just needs to go a little bit lower. Yep, and the next. Over. Needs to go 1 over, 2 over, so that's 261, 13, 12 and 14. Three down, I think, 276. Sure if I can do this with a keyboard. It seems like every time all the cursor keys just three. Okay, yep, that one's 13 instead. Just to mix it up a bit. 293. Probably about 11, 14. Still 10. A really skinny one. Here. Oops. Maybe the wrong one. Almost done. Actually that is 10 and 14 in that case. Let's get the whole shadow in. Okay, so hopefully we don't lose that, and we'll click. So we have a list of sprites. Let's see if we have those sprites available in the main editor. Excellent, good. I was a little bit worried one might lose them. I don't know if we need to keep the big sprite. We won't worry about it right now. We'll go here, add a new folder. So we'll create a new folder for our sprites. And within there we'll create a new folder for our man. No, it doesn't like changing the case without changing the word. There we go. And we'll move our sprites that we've just created into there. So take those. Don't actually know how to move them. Must be a way to show a tree. All in there. Okay, so we'll take the ones that look like he's moving to the right, and that one, and we will create from that a flipbook. We'll call that man point. Nope. Start again, man point. Now we've got a bit of wobble, and we probably have the frames in the wrong order. Let's slow it down so we can actually see what's going on. A bit more, maybe. Probably a bit slow, but we can adjust that, maybe actually slow it down a bit more if we want to be able to see each of the different frames. Seems to be it's maybe a bit of guesswork here because I don't. It seems to be jumping. I'm not sure if the. Adjust the sprites to the right, right, and right. There we go. Hopefully. So sprite 3 clearly is either standing still or generally just idle. 12, 9, 11, 10. I don't know if I changed that one. So that's the first one. That one and that one. I think they were the same, aren't they? At the end. So we get these in approximately the same right order. So to make it look less jumpy, because obviously when we loop round to the start, he's going to just go back to, I think from that, there. Duplicate that one as well. 11 and 11. So we're duplicating some of the sprites, see if we can get it to look a little bit more walking like. I don't know if we want sprite 10 or not. I'm not sure that that's right either. But we could obviously spend quite a while messing with that. So that one's 10 by 14 and 10 by 14, and that one's 9 by 14, and that's 11. So there's one that's slightly smaller. Just think that doesn't make any difference. And one that's slightly bigger. Change the pivot point for the slightly smaller one. So it'll be 5 in that case. A slightly smaller one probably needs to just come back by 1 point, I think. See how that looks. Save that one. So his eye, except for when the head moves, looks about right. The background obviously goes a bit weird, but we can live with that because that's just the background. So that seems like it will do for now. We've got the right hand one working in a manner of fashion. So now we'll work on going left. Looks about left. So pick out all the left frames, create a flipboard, and that would be man left. And we'll do down, man down, and 1, 2, 3, 4 frames for going up, man up. So we'll create a new folder for our blueprints. So we've got all the animation frames for the 4 different directions, and we're going to call this, we'll call them units. Probably a bit of a stretch to call them units in a game like this, but we'll call them units. And we will also, from our texture icon, we will get the light animation, because the light animation is used when the units spawn or when they die. So this one should be just as tedious to dig out all the sprites, but at least we only have to do it once. Oops, I think I lost that one. So we could try and make all of the particular images the same size as this one, but I don't think there's enough room around them, but we'll give it a go. Again, just adjusting all of the numbers so that we get the sprite, and it's 15 by 19, so we're going to try and get all of them to be 15 around the same center point. Now I don't think we'll be able to do it for these ones actually. 15 by 19 is going to pull in bits of the other images which we don't want, so that's not going to work. So we'll just fit it as best as possible. We need to take it 2 down, 3, and 4 smaller. 15. Don't think there's any benefit in actually having it any different size, so it's 11:15. We'll see if we can do 11:15 now. Now I'd have thought we'd be able to use the drag points, but unfortunately they don't work. Don't know what button I should press to make them work. Yeah, doesn't seem to be any way to actually edit those, despite it saying drag handles to adjust source region. It doesn't work. Back to the manually editing. Need to move this over about 5. Oops, wrong direction. Just thought I was editing the X position then, and I wasn't. So I'll have to adjust the pivot points for each of these sprites so that they all line up when we put them in the animation, but that should be fairly easy to do. 249, oops, too much. 246. It's only going to be 5 width. Move that down by 4, 76, 75, 7, no 9. And finally, I'm quite sure what the additional pixel is there, but we'll keep that just in case it's part of the animation. Take it down to 5 more, so 3, 1. Another 5 down. 176, 75, it's only 3 across, it's only 8, 7, okay, that's great, so we can close that, we can move them into our, into a new folder, so we'll create a new folder for our, don't really know what to call it, spawn light will do. Oops. Leave that here. And kind of likes it in that order because they're the order that I've extracted them in. Oops, span light, spawn light. So I need perhaps another directory for our animations. That actually doesn't look too bad. Doesn't quite look like it does in the game though. So let's quickly start a game with the original. See what the difference is. I think the frames are all centered okay, so the general effect is middle. We haven't dealt with the transparency. But let's see if we can see why our current animation doesn't quite look like it does in here. Yeah, so it definitely goes up and down. Maybe that's the issue. It would be nice if the frames had their preview, so we could see what the difference were between each of the different frames, but unfortunately all we have is the name. We could go through them and name them. Maybe just light 2 actually. Run out of small, medium and larges. 3, 4. So at least by doing this we can see now on the animation, we can see their actual names, so we can try and order them with a bit more sense. Might make it easier to get the animation correct in here. So we definitely want to start at number 1. That kind of looks alright. Let's try it again. So if we just pick our people up, put them back in the house. So yeah, it definitely goes from big from small to big and then back to big. So we'll duplicate. Don't think we can do. Can zoom it in, but zooming it out you have to get the right place. So we'll put the 6 at the end. 5, 4, 3, 2, and 1. Okay, I think that looks a bit more like it. Still don't quite get what that extra pixel is on frame 1. We might have to take that out, but for now, that looks about right. There is a little bit of a deviation. I think the first frame, if we slow that down to some really slow speed. Start again. So the center is just quite low in that case, and I think the center moves up by 1, so we want to sort that out. I think that can be sorted by that, removing that additional pixel. I'm not really sure why that pixel was there. It doesn't seem to serve any purpose. Let's just see if we can see it in here. No, I don't see it. I'm going to take it away. So if we go to the first sprite, edit source regions for it, select that one, select that one again, and just move it down by 2, so 177, 5, save that. That's much better. So our light is working. Okay, so we have our spawn light, we have our men. We'll create a new folder in our subdirectory, in our sprites directory, and just move the animations in there, because we're going to generally be working with the animations anyway. Again, we'll do that here. Try and keep these assets organized. Okay. So now we will create a new blueprint for an actor, and this will be our man. Now, that scene examples that I saw replace the original. So let's just run through that again, just so it's clear. We create our new actor blueprint, and what I did was I added a new component for the scene, and then I replace the default scene route with a scene. It says this scene has transform and can be attached to other scene components. Perhaps that's not the right thing to do. We don't really need to do it. I saw other people do it. I'm not really sure if that makes any sense, but it doesn't matter because we can always do it later. But now we've got our actor. Before we brought in just the single animation, but now we've got 4 animations for each of the different directions. So we're going to drop them in. And we're also going to drop in the animation to spawn it. So we know we can just make the sphere a little bit smaller. It doesn't necessarily get rid of it, but it's as good as, because I've done it to 1. Now, we've actually got all 4 of our animations. I always put the spawn light under there. We don't want that. Get out. So we put the spawn on accidentally under the man, but we didn't need to do that. So we've applied all these animations to our route, and it's looking a bit of a jumbled mess. If we place our actor in our world, take that out, and we will place our man. rotate him around so we can see him. Oops. Let's try and get the cameras and the angles all right. So bring him into the frame. Straighten him out. There we go. So he's still a jumbled mess. So we could really do with sorting out the transparency on that texture. So we know that's the is this? Hopefully it's that texture. Let's have a look. So we can see the texture that we've used. Yeah, it's the texture, it's the red one, not the red. So we can go in here and add a chroma key texture, and we select this kind of ugly green colour, and now it's gone. We save that and we go back and we can see that the green colour has been removed from all of the animation frames. It's always quite nice when that happens. One of them, yeah, it must be just the way they overlap, because it looks like there's a little glitch over there. But so we've still got a bit of a mess with all of the different textures overlapping. Sorry, all of the animations overlapping. So from here we need to choose which direction to go. Which direction we want to be in. We need to choose which flipbook we want to show. Now we know when the actor is spawned, he's going to always spawn with the spawn light animation. So we need to hide all of the other ones. So we don't want any collision, and we don't want any overlaps, and we don't want it visible. And we'll just do the same, because when the people move around in the game, as we can see, they overlap each other. They don't really care where they're going. So we want to replicate that. So we turn the collision off and make it not visible. So turn collision off and make it not visible. So that's the easy bit. So we should, if we go back to our main, yes, we just now see the animation for the spawn. And unfinished play. So the spawn animation is going to play when the character is created. Once it's finished, an event will fire for finished play. Now, because we know as soon as that finishes we need to pick a direction, we can, using the general logic that we had before, add a custom event. And what was it? Timer. Set timer by event, that's the one. So set timer by event. So we attach our custom event to our timer, and we'll set that to that. So when the spawn light animation has finished, we then begin this timer. We do want the timer to loop. I'm not sure if we can change the time during each loop, because we want the character to change direction, but we don't want the character to change direction in an orderly fashion. We don't want all of the little men to change direction every 2 seconds. They'll all be following the leader. So we need to add a random time but we'll deal with that a bit later. So we set up the timer. We know then that the timer event will occur, and from that we want to set the flipbook, and we want to set the flipbook based on the direction of the character. So we need some way of knowing which direction to go, and there's many ways we could do that. We could do it with some enumeration to determine the value. We could do it with a 2D vector to determine the direction. We could do it with a string or an integer. I'm not really sure within the context of this engine which way would be better, but we only have 4 directions, so we're going to go for direction. We're going to go for an integer, and compile it, and we'll give the default value 0, and then we'll use our select object and give it the oops, not set, we want get. I think we can actually, something that I saw today was drag it straight into the pin, so we can drag straight from here onto the pin we want to connect to, and we need 4 options for each of the directions, and then we need our 4 animations. So we'll keep it simple. We'll do kind of clockwise rotation, so we'll start with up, right, down and left as 0, 1, 2 and 3. And the return value gives us the same one of the options that we've passed in, so we've got a flipbook, and we just want to set the flipbook. Set flipbook. Okay. Can we not? Can we not just set it? Or do we have to set it like that? So it looks like we can, yeah, it looks like we can set the individual flipbook like that. Oh, okay. Oh no, we didn't want to set sprite color, did we? Not quite sure what I clicked on then. Set flipbook. Man down. I don't know why we can't just do that way from the start, but we obviously can make it do that way. Oh, the return. Paper flipback component object reference is not compatible with paper flipbook object reference. I mean, they're the same thing, so I don't know. That's a bit annoying. Our select doesn't seem to want to be able to connect. It can connect to the target. Let's just, for argument's sake, just see if this works. So we'd expect that when the animation completes, the what's it saying? This blueprint itself is not a paper flipbook component, yeah. No, still doesn't seem to work. So we can Maybe the answer isn't make a flipbook. Maybe the answer is to make that flipbook visible. Set visibility. Toggle visibility. Set visibility. Does that connect to that? Okay, great. Make it visible. But that, I'm not sure that's going to work, because what we're going to do is set one to be visible. That means we're going to have to at some point set one of them to be invisible. Perhaps the answer isn't to actually have the flipbooks in here and just simply have one visible flipbook, and we'll change the animation, change the source flipbook to it. But firstly, we'll just make sure that this works. Our direction will be 0 by default, therefore we should directly go from the spawn animation to the moving up animation. That does not seem to work. So is that because the animation is looping, or the animation is looping in this case? Don't know where that option is to stop it from looping. Small light. Play rate is 1. Sprite color. Materials, physics, collision, lighting, visible tags. Don't know why it's looping. Well, it is looping by default, and I don't know where to change that. I would have expected it to be somewhere in there, but it wasn't. So when we begin to play, we just set the looping to false. That should solve the problem. It does stop looping correctly, but it didn't trigger our event. Oh, it did. It did trigger the event. Maybe it depends on when, yeah, so when it is within the frame. And there we go. Yeah, so we want to also make sure that we do that straight away. So if we begin the application when it's near the end, it doesn't seem to work correctly. It certainly doesn't remove the previous flipbook. So I'm thinking that having multiple flipbooks within the scope is not going to work very well. But we can take the animation frames, the actual flipbooks, and rather than adding them directly to component, flipbook component. Okay, so that's each of those has added the individual paper flipbook component. We don't want to do that. We want to set the flipbook. So can we don't want to add the paper flipbook, we just want to reference the different way of doing this. Okay, no. Flipbook. Let's take all of the other ones off. By default we don't want it to loop. Well, actually by default we don't really have anything, so set flipbook to spawn. And then play. So we obviously won't get there. We'll keep that one. We won't keep that one. Yep, that's a bit better. So we don't have all the flipbooks in there, but we do, when constructed, use the right animation. We also want to make sure that it's not looping. Got lots of references to our paper flipbook, so we just take them all from the single one. Make sure we're not looping. So the spawn animation is set by default, turns the looping off and plays it. And that means our event should occur. It won't occur because we've tied it onto the wrong thing. So we need to tie the event back over to this one. So we actually need to attach to the right thing. So now, again, if we just play that, did that work? Yes, we can see the little bit of execution that goes on down here. So now we can set the flipbook. So one problem is we can't seem to reference the actual flipbooks. We have to call set flipbook multiple times. So I think for this should be able to do switch on int. I'm going to do it like this instead. So it's almost exactly the same, a switch and a select, almost exactly the same. It's just which way do you put the different parts. It's quite neat, good way of saving code. Again, there may be a better way to reference the actual flipbook animations in here, but this will definitely work. So we'll tie all them up. And tie them all up to the flipbook. Be the target. And then we'll tie each of this. So we'll do down, as we do before, right, no, up, right, down, and left. Clockwise rotation. So now we've set them all. We can probably functionalize some of this moving forwards, because we're going to have to duplicate the looping and the playing. In this case though, because the animation is going in a direction, we do want it to loop. So the looping behavior may be retold, but just in case we change it, we'll make it explicit in this code. And every 5 seconds it's going to change direction and play the appropriate animation. Tie up the final bits. So let's see what we've got there. Again, we seem to hit a point where if the animation... Oh yes, same problem as we had before. We have that 5-second delay. There we go. So hopefully in about 5 seconds it'll change direction. Nope. Not seeing the custom event fire. Would expect this to occur. The set timer of our event is set to loop. Set timer is set to 5 seconds. Perhaps we'll just reduce that. See if that makes any difference. Yeah, okay. Obviously it's not going to change direction. We don't change the direction. So we need to change direction when the event happens. We also need to know what the direction is so that other things can use it. So we're going to set the direction. So just random integer should be fine in this case, the max. So as it says there, it's max -1. We want max to be 3, so we put in there 4. That will be what we set our direction to, and pass it straight to there. So here the event will occur every 5 seconds. On that event, just move that out of the way. On that event, we'll switch the direction integer to one of the flip books and set it and loop it and play it. So now if we just set that to 3, so it's not happening too quickly, and play, hopefully in about 3 seconds. There we go, he's changed direction. Now obviously the direction, our left hand animation isn't so great. Our left hand animation is a bit slow. Obviously the random integer may be the same direction as we're currently going. That may be okay. I mean, that would give it the impression that sometimes it doesn't change direction, so we wouldn't get that uniform every character changes direction to this as such, but it's still going to happen too regularly for our army of people to look kind of, I hesitate to say realistic, but it'll look a bit uniform if they're all changing direction at the same time. So the speed of this one is 15 seconds. We do seem to have a little bit of green between his feet, but we can deal with that another time. And there's our other one. Our moving to the left is 15. Our moving to the right is 1. I don't know if 15 is good enough. 15 might be too fast once we actually get to moving the character around, but we'll just start with a uniform animation time on each of those. So just save all of those. Just happened to be right that was the problem, not left, but I think we're obviously looking at the character within the window from the opposite direction. So while in that case he's definitely going up, and now he's going right, now he's going left. Chances are the actual direction is saying that he's going the opposite way to what we see, but that's okay. So he does look a bit quick, but we'll go with that. Now we're going to want to move him. We're going to move him based on his direction. So again, we'll just switch on that direction, and we'll move him every tick by a certain amount. So we know that we change direction on this timer, so we can simply use the direction as is every tick. And what we're going to do is create a 2D vector. Probably not in the context of that. Make. I was looking for create and it's make. So make a vector 2D. Now we want to from our scene root get our location. Going to give us a vector, a 3D vector. So within the 3D world, if we find our little man, within the 3D world, this little person has, what is it, details, has a X location, a Y location, a Z location. The colours all match up, so we can see that the blue, the green and the red are displayed by the arrows. We don't care about the X direction as much as we care about the Y and the Z. To make our person move around on this 3D space, we can use those two directions. The Y should be approximately alright. It actually looks like it's flying at the moment, but let's just try and get that camera aligned. Bring it down. So Y is actually underneath because the canvas has some width. The floor has some width. So we just put it above the floor. Now once we've got more of this in place, we'll obviously set up a proper camera for the 2D space, but because of the shadow, yeah, it doesn't actually look too bad. It'll probably look quite nice having these little guys move around. So we only care about the X and Z. So we want to split the 3D world location, and when we're moving up, let's have a look. So if we're going to leave the camera facing as it is, we've got X as our up and down and our Y as our left and right. Obviously if we look at the camera from here, it would work completely different, but we'll leave the camera in this general location, and we'll do up and down as X and left and right as Y. Again, once we've actually got the 2D camera, everything in place, then we may have to adjust those to be the X and Y and work them differently, but for now we can deal with that. So when the character, this is our direction, 0 is up based on our animation we're doing here. I guess there's the advantage with using an animation, maybe that we get clarity on what direction we're going. But nonetheless, when we're going up, we want to add to our integer. Again, that's context sensitive and that's not going to work. It's actually a float. So we want to take our x, and we'll put it in the bottom one just because of how this lays out. Add 1 to it, and we set it, in this case, as our x, again because that's going higher up. So if we look again, our current location is 72. If we increase the x, we move up. So that works. We'll just connect everything else up. So that's up. And when we're moving up, we want to keep the y the same as it was. Oops. So in this case, we're going up to the right. So again, the right is plus, but in this case we're actually modifying the y. So we tie that to the y, not to the x. And then tie the x to there. Down. Down is the x, so we take the y from there. And the x from here, but it's now actually -1. And then finally this one again, which is the y, so we'll take the x from here, the y from there, and the y is -1. So our return value is a 2D vector. We actually need to change where our sprite is located. I think we'll do set world transform. I don't know if this is what I want to do. I'll give it a go. There's it, get world transform. Split that. Keep the rotation as is, keep the scale as is. Break that. Yeah, so we've created multiple 2D vectors for our new direction, but if we were to tie them straight up to the transformation and then tie that up to the set world transform, we'd have to repeat the made transformation, etc., etc., over and over again. Just in the interest of trying to actually get this to work, we're going to create a new, not a dispatcher, not that. Create a new local variable, new variable. There may be components, pre-created components that we can use to simplify the movement. That will be my research for tomorrow. But for now, we're going to set the movement vector depending on our direction. I don't actually like the way this looks, but again it should be functional. And then down here we've got the world transformation of the sprite for our default scene route, and we're setting it. So once we've switched to the particular integer, any one of these comes back down here. Set the world transform. Now we know we've got this movement vector that's going to give us our change in x and y, and we've got our location that we are creating a transformation of. So I think yeah, this is going to get a bit ugly. But again, we'll run with it. Run with it simply because we've got it almost all set up. But that doesn't look good. Not quite sure where our little man's gone. Because we moved him around before we started this, the camera wasn't actually looking at him. There we go. Let's just save everything a minute. Resaving. It's because there seems to be a little bit of a lag, so I don't know whether that meant that it was struggling a little bit. When we tie up our movement code, if you can call it that, our little man disappears. So I think we've got the movement stuff quite wrong. I think what we'll start with So we'll start with something simple in terms of moving our actual man, just so that we can prove that the general concept works. A floating pawn movement might actually be what we need. What have we got here? Speed. Okay, so we've added this floating pawn movement. See if this makes the movement easier. And we've deactivated it by default, and we will activate it actually on the completion branch sequence. Completion of the spawn will activate it. Oops. I can close them anyway, all the footboards. So we don't have any direction, we don't have any speed. We don't have any velocity. So if we give that 1 velocity and the X, see what happens there. Well, he's either moving really slowly or he's not moving at all. I'd say that's not moving at all. Back to that, I don't really know what it's doing. Let's give it a bigger number. If in doubt, make it a bigger number. I think that this should be active now. Make sure it's reaching that point. Yep. So we are activating our floating pawn movement. But even with velocity, even with a velocity of 100, he doesn't seem to actually move. Bit of a shame. Does he move in any direction? Maybe we have to do something with this. that? Just see if making auto. No. So it's not so much that it's not active, it's just that it's not actually doing anything. It's not. Yes, that one sounds familiar. What happens now? No lot. Pawn component, pawn movement. Pretty much just guessing until it moves. So I don't know why our pending input vector for our movement component doesn't contain any data. We add it, we consume it, we get it. Let's just see if it's going to do anything. Okay, so it says, is movement input ignored? If there is no pawn or update component, returns true. Do we need an update component? Reattach that to the pawn. When you set the movement to plus minus 1, should it add to the vector equals vector plus 1? Yes, if I was trying to do it with the modifying the vector itself, then I think yes, we would have to add the individual properties to the vector, but we're trying here to utilize the pawn movement, which in this jumble of code here has various components. I remember using it briefly for a little prototype that I did some time ago. And with that, it should should have some pending movement vector information, which is updated itself by the velocity that we've set in our particular component. So every frame or every tick, the floating point movement should update those values, and by consuming it, return to us a new vector, but also apply that vector directly to the pawn that it's connected to. Based on this property, it's ignoring the input, and it's ignoring the input because there is no pawn or update component. What I don't understand or know is why it considers there to be not to be a pawn, where obviously our top level item is an actor, which I believe is a pawn. Maybe there's a problem then. A pawn is an actor, but an actor is not a pawn, so maybe the movement vector stuff isn't going to work because it's not a user controlled component. So let's just scrap that idea. Now we can go back to the original. We're trying to shortcut the movement there, but that didn't work. So let's just make this thing move upwards. Set world location and get world location and add float. So again, we've got an issue. We don't want to actually move it until after the spawn animation is finished. But again, just in the interest of demonstration, we will move it along the x-axis every tick. So this should just, yeah, shoot off into the distance. At least we've got some movement. Hello, Eva Vectress. Hi, thanks for stopping by. So, as you say, Howard, earlier, yes, in this case we have a vector, we've added a number to it, and we've set back. Works perfectly. We don't take into account our current direction, we don't take into account the fact that we're still in the spawn animation, but well, at least we move. And when we're actually in the moving up animation, as we saw briefly as he ran off into the distance, the speed that we were moving is actually not too different to the way that the frames of the animation. So we need to try and take this jumble here, where we were trying to account for our direction, and apply it here. We can say that direction 0 would be non-moving. We obviously want to adjust this code so that 0 doesn't actually stop us moving, because once the character with the original game, once the little people are actually moving, they never stop until they die or they are moved. So we want to ensure that they move around, but we can do that by a random integer in a range. So for the actual direction, we want to go 1 to 5. I think that's correct. Greater than or equal to the minimum number, so which was 1, and greater than or equal to max. Sorry, less than or equal to max. So in this case, it might actually be 0 and 4. So 1 and 4. we need to add another option pin here and just readjust these. So again, I think we really are going to have to change that to any enumeration just for the clarity, but we should still get that. We'll just break the tick. Let's just see if we haven't broken the animation, so we've still got up and right and hopefully all the other directions without any kind of stopping, except for when I move the viewpoint around, without any kind of stopping, so that's fine. So now we know that direction 0 isn't going to move us. So we switch on our direction over here, and so inevitably we want to try and avoid this kind of duplication here that we're going to get. I don't think we need any of that. But again, just in the interest of getting it to work, we'll just drop down all of this. Let's try and select the right pieces. One. There we go. So we dropped it down 3 times. Try and align it better later on. I don't think that we need all of this all over the place just to get one value of a vector to be updated. This is going to work if be a bit verbose. Actually, we've got it 5 times. Too keen. So we've got all the different directions. We'll adjust their numbers in a moment. Tie them up. About in the middle. So when we are going up, which is number 1, we need to increment the x value by 1. When we are going right, we actually need to increment the y value by 1. So the x will go straight into there, and the y will come down from here. And down, we actually do -1, and then we do -1 for left, but again, x will go straight through, y will come into there and out of there. So that should be all the vectors all tied up. Sorry, all the directions tied up to their specific world direction. Now we could create a new vector, adjust the vector, apply it, kind of remove some duplication by local properties, but for now should be fine. And perhaps we don't need all the duplication in there. That's definitely one that we can get rid of, because we don't need to constantly get the world location in multiple different ways. We can just tie the x value here to the 2 that apply, up and down, and the y value to the right and left. And we can also apply, so we know the y value goes straight in, the x value goes straight in. In this case, tie up all the z's, so they never change. Oops. So we're going down, which is y, so we need to take the x from our original location, and in this case we need to take the y. Bit spaghettified with all the lines from the world location, but it is marginally better than having multiple get world locations for the same thing. And as I say, ideally we would be able to remove the set world locations with some other code. Perhaps a function would be the smart move, but let's have a look. So our timer is going to trigger every 3 seconds. That should update the flipboard and the animation and our character movement, and our event tick should first start with saying our default direction is 0, so we'll come straight in here and it won't do anything. And as soon as our animation is completed, it will then have the correct direction to apply one of these changes. When the direction event occurs, it will change our direction and it will then update the correct value within our world vector, hopefully. Oh, well, he ran off. We're going to be a bit of a chase in game. Let's start it again. Where's it gone? So he always starts from over here somewhere. So again, this is where kind of a proper bounds for the movement, proper camera will come into play. So we'll probably work on that tomorrow. But for now, we'll reduce the movement. We could have this value passed in as a variable, so that we don't have to adjust it 4 times. As a speed variable, plus minus it accordingly, because obviously we've got the math based node, we can just change whether it's plus or minus. But for now, again, we've just got it in place, so we're just half the numbers, minus 0.5. Should hopefully make it a little bit slower, easier to chase around. It's not going to necessarily look as nice, so he still gets stuck going there. And obviously if we're on the wrong direction of him, he's going to look wrong, because that frame is not going to look right. So if we go over here, nope, he's still going the wrong direction. So the left and right are obviously wrong somewhere along the line. Either the direction he's moving is incorrect, or the flipboard is incorrect, but he's definitely having a good wander. We can fix the left and right. I think it's simply because we're using the wrong values in the X and the Y, so we'll just change this one to minus 0.5 and this one to 0.5, so that's switching the change of value to the X, to the Y value in both cases. So again, let's find the man. And go. See, there he is. So there's a bit of time where he isn't moving. But he moves up correctly, and now he's moving to the right correctly, and up again. So if we're on the wrong side of him, then the animation isn't playing correctly, but at least now he should go left and right. Yeah, he goes left and right correctly. So that's great. Let's figure out why when we start we get that first spawn, but for some reason he doesn't move. Somewhere along the line he's not walking. Stop it again, play it again. The animation occurs. We should be going in a proper direction, but it's not until the first tick which we do. That must be because, yes, we are setting the direction within the event, but we're skipping all of that. We're going straight to the switch, so we actually need to connect that up to the set. So when the event is started, when the timer is started, don't need that one. When the event timer, when the set timer by event is started, we also go up to the set and then appropriately set the direction. That will remove that kind of 3 seconds where we're meant to be going but we're not. There we go. Okay, so we have actually achieved what we set out to achieve. Technically we set out to achieve it yesterday, but such is the nature of programming. We have our little man, and he is walking around. We need to set up a better camera, and perhaps a few other bits and pieces, just so we can get more men. We could do that, I think, if we go into the bigger. Let's move this in here. So we will go into the, where is it? Settings, project settings. Oops. And input. So we'll quickly set up a action mapping, and we'll call that spawn. We'll do space. If only pressing the space actually searched correctly there. Space. And then we'll go into our blueprint for our level. Space. Maybe didn't need the action binding at all. So spawn actor from class. Ignore collision. Spawn our man. Don't know if we need. Yeah, it needs some transformation. So we'll just set that to all 0 and 1s. File, save, save. So if we position the camera and a man, so our man is going to spawn at 0, 0, 0. Now we know 0, 0, 0 is not great because he's going to be under the world, so we know we need to spawn him at least 20, maybe 25 height. So just jump back here, set the location of, is it the Z? Yep, the Z. So set the location of Z to 25. File and save that. And play. So that's our first little man there, and hopefully if we press space, well, there we go, another one. So we can just throw a whole bunch of men in and watch them move around. So that pretty much concludes our go today. I think that's pretty good. Tomorrow hopefully we'll look at trying to set up the camera more correctly for this type of game, and we'll go from there, I guess. I think this is at least some progress. So thank you for anybody that's watched, and for those that yes, they do look a little bit like ants. So thank you for anybody that watched, and for any help that's been provided. Hopefully we'll be able to crack on with some more tomorrow. That's all for tonight. Thank you very much.